Hello everyone, welcome to the Idealist Academy. Today we are going to perform another experiment, that is your detection of the cyanide oil in a detection of the cyanide in a edible oil. Okay, so this um, experiment are come under the series of the detection of the adulterant in a edible oil. Okay, so before starting this experiment, we have to know that what is this adulteration are and what is the adulterant. So simply adulteration are what? It is a process in which a substance are added into a food product to increase the quantity of the food product or enhance the flavor and the color of the food product. But during this addition, the quality of the food product are degraded and the nutritional value of the food product are also degraded. Okay, so sometimes this adulterant are also have a also have a health effect, and this health effects sometimes are what? Sometimes are life threatening. So that's why the addition of the adulterant into the food product are what? Are prohibited. We have to check the adulteration in a food product for a better health. So here the adulterants are what? It is a cyanide oil, and sorry, it is a cyanide, and the sample that we taken is what? It is a coconut oil. So this is our coconut oil. So for performing this experiment, we required these three reagents. The first one is your potassium hydroxide of 2 normal. So this is your potassium hydroxide, and the normality of this potassium hydroxide is 2. So for this we take a 11.2 gram of the potassium hydroxide and dissolve into a 100 ml of the distilled water. Now how we calculate this value? This will come under the topic of solution preparation, and the video related to this are already uploaded in our account. You can visit our YouTube channel and check that video and understand how we prepare the solution. Now the second reagent that we required is a ferrous sulfate solution of 2%. So this is very simple. We take a 2 gram of ferrous sulfate and dissolve into a 100 ml of the distilled water. Then we get what? We get a 2% of the ferrous sulfate solution. Now the next reagent that we required is a 2% of the 20% of the ferric chloride solution. So for this, what we have to do, we take a 20 gram of the ferric chloride and dissolve into a 100 ml of the distilled water. Now you can also prepare according to your need. If you want to prepare a 10 ml, 20 ml, 50 ml, or sometimes 2 ml, 30 ml. So for that you have to check the solution preparation video of our channel, so you can better understand how we prepare the solution. Then we required a burner, test tube. One more chemical that we required is a concentrated HCl. Now, when we are handling the concentrated HCl, we have to take an extra precaution, because this concentrated solution are what? They are corrosive in nature. So we have to avoid it to come in contact with that concentrated acids. So when we are handling this, we have to wear a proper gloves and proper mask. And proper lab coat, and we have to avoid it to come in contact with our skin and our eyes. Otherwise it will damage our skin and burn our skin, and even cause an irritation in our skin and also affect our eyes. And we have to avoid to inhale the vapors of that concentrated HCl, if so that it will not damage our respiratory tract and digestive tract. Otherwise it will cause an irritation inside our respiratory tract. So this is the chemicals that we required. We required 4 chemical: potassium hydroxide, 2 normal, ferrous sulfate 2%, ferric chloride 20%, and concentrated HCl. Then we required micropipette of 1000 microliter or 1 ml. You can see that. Then test tubes, micropipette tip, test tube stand and this test tube holder. Now what we have to do, we take our 10 ml of sample, sorry 3 ml of the sample, and into it we have to add a 1 ml of that potassium hydroxide. Then we heat it. Then after that, after heating, what we have to do, we add a few drop of this ferrous sulfate solution, and we acidify it with the help of the concentrated HCl, few drop. Then what we have to do, we filter it if it is required. If it is not required, then we don't filter it. Then we added a few drop of the ferrous chloride. If the if the hydrogenic acids are present, then it turn a blue color. Okay, and this hydrocyanide acids are present due to the presence of that cyanide into a edible oil. So experiment are very simple. Now take a test tube. After that, we have to add a 3 ml of the sample. Now take it. One, two, three. Okay. Then after that, we have to add a 1 ml of this potassium hydroxide. Now we have to heat it with the help of the burner. When you are heating it, you have to put the test tube like this, so that if any vapors are come out from the test tube, then it will not come in contact with your skin or with your eyes. Now after that, we have to add a few drop of the ferrous sulfate. Now take few drop of the ferrous sulfate, like 1, 2, 3, 4. Then mix it properly. Now we acidify it with the help of concentrated HCl, and we added few drop of it. Now avoid the vapors of it. Then we have to warm it. Don't boil it, just warm it. Now we don't require a filtration. If it is filtration required, then you can also filter it. Now we have to add a few drop of ferric chloride. If it turned blue, then it will means that the cyanide are present. Now mix it properly. So here it does not turn blue color, which indicate that our sample does not contain any cyanide. Okay, which means that our sample are pure, it is not adulterated with that cyanide. So this is all about the detection of the cyanide in a edible oil. I hope you will understand, but if you have any query related to this experiment, you are free to ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms. That is your Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn. and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.